So welcome everyone. Thanks for joining us today at HSE's Master of Data Science degree programs industry webinar. And we are happy to see you here. Let me introduce the speaker, Alexey Masyutin. And before we start, I would like just to mention a few formal moments. So as you see, we are here on Zoom and you have the chat and Q&A features. So if you have any questions regarding the presentation, please post your questions in Q&A feature. It will be easier for us to communicate with you and to track all questions. So after the presentation, we will have the special session for Q&A. So Alexey will answer your questions. And the recording version of this webinar will be available in a few days. You will receive the link to your personal emails. And also you can find the link to that webinar on our website of Master of Data Science degree programs website. So I think that we can start. Alexey.
Thank you very much, and hello everybody. Sorry for a little delay with our start, so I'll try to share my screen. So everybody can see what I see. So this is the title slide for my presentation. You can probably type in the chat. So it's okay. My name is Alexey Masyutin, as my colleague has said, and I work both at Sberbank. It is one of the largest banks in Russia and Eastern Europe, and it's really large in terms of global financial institutions. I believe it is somewhere in the top 15 by assets. And also I work at Higher School of Economics, and I run a master degree program, another one. I'm really glad to have my talk here today for your online Master of Data Science program. And I would like today to tell you about trends in modeling in financial industry and new arising type of risks. You know, financial people are always talking about some risks, and yet we have another one. It's called model risk. So what is that? We will discuss today and how to manage that. So basically, we will go with a small overview. What is model validation? Of course, it depends on whether you had or not any experience before in model development. And probably if you did, of course, you tried somehow to validate your model to verify its results. And for those who are quite new to this sphere, I think it would be useful. So the model validation is a global trend, in fact, because there are many consultants and such as McKinsey and Deloitte, and all of them mentioned that the level of AI maturity of different companies and organizations is really determined of whether or not they have this validation function within their departments, and how automatized it is, and how deep it is encapsulated in all business processes. So basically on this slide, you can see an arrow, blue one. It's in the below this slide. And the first level of data science culture is predictive modeling. It's basically when company uses its data to support some decisions made by humans, by managers. And in this case, usually companies use simple interpretable models, and the final decision is made by a manager, human. Next step, when the company kind of moves more to data-driven decisions, it develops more complex model, black box models. So they are called so because they stop to be interpretable. They usually take tens and hundreds of features and use some uninterpretable ways to transform them. And the critical point is also that there is no human that makes decisions. So the model is granted rights to make a decision within a business process. So this is the middle point, is rather high level of a maturity. And the final step is when the number of models is increasing within your company and organization, and all of your business processes are to that or this extent are connected with models. So usually for large financial institutions, this may end up with portfolio with more than 1,000 models, and they are being deployed at the same time, and the decisions are made based on those models in real time and simultaneously. Therefore, it arises the question whether or not all of those models are compatible between each other. Are they good enough? Are they stable enough? And what affects their performance and stability? And this, of course, drives demand for model validation. Well, also we can track in history that validation as an independent department within organizations, especially in financial industries, was kind of organized in the end of 20th century when so-called Basel agreements were adopted. Basel is a town in Switzerland. It's famous that for its Basel Banking Committee. And this is the organization that kind of writes the rules that should be followed by all European banks. And very often other countries kind of take into account those guidelines and those rules and adopt them in their economies. Russia is not an exception. We also have a central bank, or a rather strong one, and it puts much focus on the way banks perform. And also, of course, they put some attention to the way they use models. Obviously, in financial industries, the greater part of models are used to calculate the risk of losses. Especially the ones with credit risk are important. It means that whether or not when we grant a loan or provide a loan to a company or a retail customer, doesn't matter, whether or not this particular borrower is going to be delinquent or is he or she going to be a good one. Also, except for credit risk, the losses that may occur within banking industry, of course, is market risk, which is connected with usage of different financial instruments such as derivatives and managing portfolios with stocks, obligations, and those derivative instruments too. Therefore, typical bank will always use some models to calculate some expected loss due to its activity, and some add-on which is called unexpected loss. And in fact, the way bank does this defines how stable this institution is. And the central banks and regulators are really interested in that the whole banking system is stable, and they really put much pressure on banks how they build those models in order they calculate those risks adequately. So again, today, of course, there will be some cases from Russian industry because basically HSE is Russian, though international university, and my background is within Sberbank, the largest Russian bank. So we can see that in this plot above, the number of models within our institution was kind of more or less constant, right, for a number of years. But starting from 2017 and I believe 2018, we experienced a dramatic increase in numbers of models, and those models they moved just from classical risk management area to all business processes and start influencing the way bank communicates with clients, the way bank launches its products, and those type of models now cover recommendation systems and response modeling, churn models, cross-sell, upsell models, and even our own employees are kind of are impacted by those models, because we have some models that internally try to predict whether or not this employee is going to leave the company, whether or not he or she is going to be successful in some sense. And just another part of models, they're addressing our internal efficiency, such as, internal processes, automatization. For instance, we have a large IT support within a bank. Obviously, there are more than 200,000 employees, so there are many IT issues, like something doesn't work and stuff, and it generates lots of messages, and those messages are also they are channeled by models, depending on what is written in those messages. So they are natural language processing models. So just this slide is to show you that the number of models and their variety with different business processes is increasing. And also what we can see is that the share of black box models is more than half of already. It means that the way models make decisions are not always obvious to us humans. This kind of raises a question. So we really need some model management platform just to keep an eye on all that model zoo, as we say. And the way to kind of quantify model risk and put some limits to that, as they do it in classical credit risk or market risk management. So again, to add some kind of drama to that, I would say we see that regulators, they are, just a second, I think I have some messages here. Just let me have a look. Okay, everybody is fine. Okay, regulators start to discuss some opportunities that black box ML models are going to be applied also in credit risk evaluation, which is a rather breakthrough for this conservative industry. And I would say that the European banks are most conservative in terms of adopting new things. The kind of states are more open to that, I think. And in Russia, I think pretty much the same level of AI focus on different applications and implementations within the banking industry. So, and even in these parts, we see that regulators kind of admit that they can expect some black box models within credit risk evaluation. You can read those interviews or find them in Google. What happens when models can perform in the wrong way? Are there any cases that show that model risk is a significant risk? Indeed, there are many cases. And here I just grabbed one of them. Of course, when there's some great loss or a model risk case, it's not only due to model itself. Of course, always there is some management involvement too, and there is some mismanagement too, and some operational risk as well, etc. And such big cases as the one with JP Morgan, which you can see on this slide, they're not just due to the model itself. But anyway, one of the reasons why JP Morgan came through severe losses was due to that fact that the management wanted to change value at risk model, which estimates the amount of possible losses for derivatives portfolio. The management wanted to change this model in order that this limit was kind of higher. So it allowed for more risk to acquire and to enlarge that portfolio. And there was a great investigation with lots of professionals involved, and the emails were kind of disclosed, and there was sufficient and strong pressure for validation department that, hey guys, this model is going to work fine, not just let us earn our money, put the green light. And finally, validation department just accepted that, and as a result, it was a mistake. Well, it's only one example. There are lots of more, but anyway, what can we do in order to minimize number of those events? Well, first of all, you have to kind of, if your organization, and typically larger organizations have many models, if you have a large amount of models, you have to set up some model management system. So it can be called model library, and many consultant companies are providing solutions for this stuff. For instance, SaaS model risk management platform. And sometimes banks are eager to code those platforms with their own resources, and to do that like in-house development. So in our bank, we have in-house development, and this is a model management system that allows us to track the life cycle of a model from the time that from an idea to its deployment and exploitation. So it connects different people within organizations, such as process owners, model developers, model validators, management, and also the teams that are in charge of model implementations and deployment. And this platform allows us to identify which versions of models are in production right now, which which things have changed within this model version, which colors or lights of validation this model got throughout its life cycle. We will talk a little bit later why there is traffic lights under validation. So usually validation is a procedure of assuring that the model quality is adequate, and as the final result, they put a green, yellow, red light as a signal that everything is fine, you don't need to do anything, this model is okay, or stop everything, you have to retrain your model. So this is the first step to settle a model management system within your company. Another step is to automatize your model validation, in fact. And here we understand that when you have kind of 1,000 models in production, you cannot just to check them with your kind of Jupyter notebooks all the time by putting some custom code. You have to kind of come up with some methodologies of validation for certain classes of models and classes of business processes, and to run and apply those checks to the models, so you can compare them between each other, among each other. And moreover, you have to schedule those regular validation checks in order to provide some monitoring when model is already deployed. So in our case, we have our own platform, but again, there are some solutions in the market. There are a number of them, actually. We will discuss this later. Well, so basically, model validation is the key to managing model risk. And obviously, it's about checking the quality of model and ensuring that this is accurate as well as stable. And I would like to emphasize the stability issue, because sometimes we are eager to sacrifice some model accuracy in order to increase its stability, if we understand that this model is going to perform on a large portfolio of clients, or is going to be deployed for a long time. Well, and if we kind of break down the validation, it can be thought in three big parts. So it's qualitative analysis, quantitative analysis, and model challenging. Qualitative analysis is just checking whether the business logic is addressed adequately within the model, and whether or not this model is going to solve the business problem. Because very often business owner, business process owner who actually orders a model development, he or she may be not that brilliant with data science things and these ML techniques. And it's important to ensure that kind of the problem he or she is facing is adequately solved by this particular model. So here we check target events and stuff. If we talk about model architecture, we have to check whether or not there is some, so to say, leakage. If somebody has taken part in data science contests, he or she might know that sometimes when the data is prepared, there can be problems with the target value and features predicting it. So, and also we can ensure that we use state-of-the-art algorithms and approaches to solve this or that task. As far as quantitative analysis is concerned, I think it is the biggest part of the deal. And here we launch rather big number of statistical testing. So it's everything about rank ordering performance, model metrics, calibration accuracy, feature significance. Well, we analyze dynamics of model metrics within different, groups and segments, and we kind of calculate confidence intervals for them. Also, we kind of focus on stability analysis. We can do something like bootstrapping simulation if we kind of not sure about the macroeconomic environment in the near future, and we can try to assess how this can influence the model performance. And also, one interesting thing I would like to discuss is data quality stress testing. Suppose that you have built a model and it's really good, but the key thing that when you built it, of course you cleaned your data, you worked with your data and stuff, and well, the fact is that when you launch the model, the production system may be not that clean, and the data that is generated within this production system can be prone to different mistakes or missings or outliers and stuff. And therefore you can try to simulate and to kind of a little bit to spoil your data, just to create randomly some missing values within your data set and analyze how your model performance decreases. And the good model, robust model, will show some, of course, will show some decrease in its quality metrics, but it's not going to be that dramatic. And this is a good way to kind of challenge your model whether or not it's robust to this kind of bad quality data. And the third part is optional. It may be the case when our validation team can try to build an alternative model by just trying to overplay the developer's team. It happens for the most important models when business owners are interested in that. I think I'll show, I'll answer some questions. There were some questions. Okay. What is MAU? Monthly active users. It means that there are the slide I show with the model management system. It showed how many people, how many developers, validators, and business process owners are using this every month. And again, so it looked like MLOps and model drift analysis in a productive environment. How to handle scenarios in order to little human interaction is needed. Well, basically, yeah, if we observe that this or that model is showing poor performance within business process, and it's already, of course, deployed, and we perform this validation for this model, it's red, we put a recommendation to rebuild this model, and depending on the model's significance, or model importance, there are certain terms, there are certain deadlines when this should happen. And we also, as a validation team, kind of in charge of monitoring those deadlines and escalating if they are violated. Alexander Kuznetsov asked, it will be about stress testing financial institution, capital adequacy, etc. And econometrics implementation in banks. Well, I think the presentation today is going to be about model risk itself, because if we talk about probability of default estimation or expected loss estimation, there are more kind of classical types of risk, which are well covered within literature and standard university courses, while topic of model risk is still not that, this is still an open question. There is no handbook on model risk which kind of answers all questions. There are certain books on pricing model risk. So when we try to evaluate how wrong our pricing model can be, which estimates the fair price for derivatives and other financial instruments. So today we're going to talk more about model risk. Okay, so this slide is about those quantitative analysis group of tests, and sorry, for some tests we left Russian names, so to keep our weapon secret a little bit for you who doesn't know Russian. But basically, you can read these sub-headings, and those are about data quality, accuracy, forecast, stability, concentration. I will comment on concentration. It means that suppose you have a model which kind of is really prone to outputting very similar predictions all the time. So there is not much variance within those predictions. It means that the concentration of forecast is too high. It can be a hint that your model is not that good. PDP sharp values for black box model implementations on the right are special techniques that are widespread. PDP means partially derivative plots, which show the incremental effect of changing the factor or feature of the model by 1% and corresponding model prediction increase or decrease. So it allows us to even for black box models, it allows us to grasp which are those interdependencies between features of the models and how the prediction of the model is affected by changing those values. As far as specification is concerned, we check how the initial factors were transformed. Are there any problems with, target leakage, or is there any problem with, over trading of stuff? So when we have done those tests and we fulfilled our validation report, we kind of show that, okay, we have validated 1,000 models and 300 of them are absolutely okay, 300 of them more or less okay, and say 400 they need something to do like rebuild or something, hypothetically, right? It means that model risk estimation is is made through percentage of models with the red validation result. Well, it's not very interesting actually, because the thing we have to and we need to know is how those red models impact the financial losses or benefit forgone that our institution can face. And this is a great challenge to translate model metrics, statistical model metrics, into financial result for this particular business process. It requires methodology as well as business process parameters, and you have to make a lot of communication with business owners and to make your estimates more or less close to real life. So, and this is what we're going to talk about today a little bit, how to bind those statistical metrics of model to financial result, and after that, how to build some forecast of your model performance metrics and translate how much money you can lose if the model the case. So let's go to that part. But before moving to this part, again, I'll look at some questions if you don't mind. Can you provide some RLS to buy books for this to study? I think yes, I can. There is a good book like Understanding Model Risk. I will drop this link. I'll look for that. Then the second question: how can we align the model risks among different model families so that they can be comparable? For instance, market credit and financial crime models, etc. things. So this is a very good question, because the only way to align them is to translate all those things in financial losses that can be driven by those models. And until this is an industry standard, usually we use percentage of red models. So basically, for each division or for each department or for each business process, we can calculate the percentage of models that are red ones. And we can say that if this percentage is higher than some particular level, so it's a problem. And business owner and the management should do something about that to kind of reprioritize their redevelopment and retraining. Also, I would like to say that models are not equal by their importance, and there are also some way to diversify them. So just to, depending on the number of clients, the model impacts and stuff. Well, I think a look outside the box should be made. A model works with data. So the question is, if a model doesn't perform, is it the algorithm, for instance, XGBoost, the hyperparameters of the data? Maybe a holistic view of the complete data science flow is needed in order to assess risk and impact. I absolutely agree with you, and this is what I tried to emphasize when I showed you the stages of validation, stages of model validation. So I absolutely agree. Can the organizers clarify how the online master's program relates to risk management? Oh, probably I will try to answer. You know that the good thing to start with is to learn how to build models, and the good thing to learn about which algorithms are applied that are better applied to which data, and how they are tuned, and which programs and which libraries you need to do that, and to acquire those skills. But the next step is to understand when you can do that. You can do that with the help of the master program, of course. And the next step is just to understand that when you build those models and you've acquired some skills in using libraries in Python, etc., it's important to understand that they are implemented in real business processes and they drive model risk. I think that's why it's important. Okay, I think I'll go on with the lecture and we will return to questions later. Oh, sorry. Again, model risk is kind of has different components. The first one is model decay. So the first one is that model quality decreases over time usually. Train model, but you studies master of data science online program, and you do not know that there are a certain number of better ways to build it, and so there is a better challenger model, and you ignored it. So basically, if you don't do that and you use the better model, you earn more. So this is a point. And the third thing, even if you have an ideal model, it's important to understand that you have to do something with those predictions based on your model. Every model gives you a prediction, and it's up to you. It's up to business processes to automatically implement a set of decision rules based on this model. For instance, for credit scoring, it's a percentage of clients that are declined, or the threshold of probability of default that is tuned in order to say no to clients. For communication campaigns, when you use recommendation systems, again, you have a vector of probabilities that for this particular product, your client is going to be interested with that probability. And you cannot just, you also have to translate this to binary decision, whether or not you're going to communicate to that client this product. Therefore, you have to correctly tune your decision strategy. So basically, again, for your interest, we have this matrix. Of course, some of you who built already models of binary classifications are rather familiar with that. This is a confusion matrix, and we have two sorts of mistakes that can occur within a model. And generally, the better you do your model, the less those mistakes are. But given your model, if you fix your model, you cannot minimize those mistakes simultaneously, just because in case of, again, credit scoring, if you try to decrease true positive error, false positive error, it means that you try to provide a loan so basically to the larger number of clients, and you try to not to say no to anyone in order to not to disappoint your customers. And if you provide a loan to everybody and your model says, okay, there is some probability of default, but nevertheless, we kind of provide loans to everyone, it means that you're going to have false positive at the level of 0. So you didn't reject to anyone, so that's great. So there is no false positive. And on the contrary, you have very, very large false negative, because if you accept all the clients, you as well accept all bad customers, and you experience severe losses. So you have to tune that, and your financial result at a very simplistic way could be calculated as that one. So number of good clients in your general population minus false positive error, subject to your current model, multiplied by some margin, which is average value we earn due to one good loan. And we have to subtract some false negative, and the things we are losing in case of default, it's called loss given default. Again, if you provide a loan and the client is not paying well, we kind of ask other people to motivate him or her to do that through collection process, and it can, so we do not lose the whole sum. Yeah, we use a part of it, and this part is called loss given default. So basically, if you calculate this for your portfolio and for your particular model, you will have some financial result. And after that, the interesting point you can do is to plot that on your graph. Okay, so what do we see? On y-axis, we have financial result schematically, and on the x-axis, we have accept rate. So this is accept rate is the thing I told you about. Suppose you have a model and it outputs the probability of default, and then you try to kind of adjust your cutting rule. So which level of probability of default is the one that you consider to be too risky, and you do not provide any loan if the customer's estimation of probability is higher than this level. So you can vary this number, you can vary this threshold, and for each value of threshold, you understand that I accept that percentage of incoming loan applications. For instance, if I raise this threshold and I accept everyone who, suppose we start from, if probability of default is higher than 10%, I reject. So, and suppose that 50% of your loan applicants satisfy this rule. If I raise this threshold and I say that, okay, I reject if my probability of default threshold is 20%, then the number of clients that are rejected is less than 50%. It's something like, I don't know, 30%, suppose. And in the first case, you have 50% accept ratio, and in the second case, you have 70% ratio. So accept ratio is the percentage of clients that you accept. So by varying this threshold decision rule and corresponding acceptance rate, you can have different false positive and false negative errors. And I think you will discuss within your master online master program on data science, you will discuss thoroughly false positive, false negative errors, and how they're dependent on different classifiers and how to minimize them, etc. And here in the gray line is some model. And again, as I said, if our acceptance rate is 0, it means that we do not provide loan to any customer, and we do not lose any money, and we do not earn any money. And our false positive here is maximum, and our false negative is 0. On the contrary, on the other side, when we have 100% accept rate, it means that we provide loan to everybody, so no one is disappointed, but except for us, because false negative is maximum and false positive is 0. So somewhere in the middle, there is an optimum. Well, this slide wants to tell you that if our model has better quality, then in general, you will have the better shape of this curve. And with proper decision rule setting, you will allow you to reach higher financial result. Well, as soon as we discussed the way we translate model performance metrics into financial results, we now understand that we can use this knowledge and techniques to move from traffic lights validation system to financial materiality, and to prioritize our activities based on financial results. So if we see 10 red models, we will start with the one we have higher financial impact with. And this changes the way we put our deadlines and the way we use our IT resources and human resources too. Also, it will allow us one day, I think, as in the classical risk management, come to some model risk management in part of capital estimation. Well, so how can we now kind of move to this VAR-like estimates for model performance? VAR is value at risk. This is a way to talk about your risk as the amount of losses that will not happen with a certain probability. So this is a probabilistic estimates or a quantile estimate of the loss distribution. And this is the kind of limit that we're, with some level of confidence, we're sure that we're not going to exceed this level of losses. Is there any similar for this kind of model risk? Indeed, there is. And in order to calculate value at risk, we will consider model performance metric, its dynamics. And typical picture for that is that you can use your historical data to train a model, and suppose your data has some time structure. For instance, the loans issued in January, loans issued in February, loans issued in March, and so on. Therefore, for each month, you can calculate the Gini of your model, or ROC, or AUC, you know, area under curve metrics, or any metric you like, F1 and stuff. And you try, when you train your model, you try to provide that your model performance is stable over time. And if you see the training and out of sample part of this data, which is green line, it's more or less around one average level. And after, when the model is deployed, we have some trends, usually of decreasing metrics. It happens due to different clients. So the distribution of clients' features changes, or macroeconomic situation changes, and your performance is decreasing. And we are interested in building some statistical predictions for those model performance metrics. Meta-learning can help us to do that. Just a couple of words about meta-learning. So it's a rather quickly developing area of machine learning, where we try to extract some metadata about our ML model performance and try to predict it by applying, again, ML methods. So a meta model is a model trying to predict some model attribute. Usually it's model performance metrics after its launch. Of course, we talk about out of time calculations. So when our model was trained on a certain time horizon, and then when it is launched, we can't. So this is a new data to ours. In this case, meta features are really various. It can be GDP dynamics or some other macroeconomic features dynamics. It can be represented by dynamics of initial model features distribution, its hyperparameters or model types, any other information that we know about the data quality that can be measured at the stage of development of this particular model. The world of meta features is really big, and it's even larger than a number of features for initial model. Just to say, we know that meta-learning is also applied in different spheres, such as AutoML libraries or hyperparameter optimization, when we use experiments of machine learning. We use results of machine learning experiments in order to say that, for data with small number of columns, we better use decision tree, and I don't know, with a large number of columns, we use some XGBoost, etc. Again, as I said, it's used in model performance prediction. Well, basically, the way to come up with valued risk estimation is as follows. We have to prepare our data, and we have to define our target. So basically, it depends on the model type. It can be Gini or accuracy ratio or F1. If we deal with regression type models, it's going to be root mean square error, mean average prediction error, log loss, or something. We calculate its trajectory over time using some aggregation periods. It can be a week, a month, or quarter, or even a year. Just be sure you have enough observations. After that, you can kind of merge, kind of add some macro factors for those periods of times precisely, and try to look for some correlations, or better say, you have to do some thorough time series analysis, taking into account non-stationarity and stuff. As soon as you come up with some good meta model, you can simulate different factor values, feature values, feature values, in order to perform what-if analysis. And this will allow you to build some simulation of your future model performance. If you have this distribution, then you can calculate its quantile, which is a value at risk estimate. So it's very similar to the things they have in market risk. But in this case, we're not analyzing the returns of any assets or returns of derivative or financial instruments, such as stocks or indices. We use our model performance metrics as an object of analysis. Again, return to the first part of our discussion. I talked about that when you have a platform that allows you to automatize your validation and to set some monitoring system for the model zoo, it's easy to collect this data, because every month or every week you have the model performance result, and it's stored within your database, and you generate those metadata for a large number of models every month, every week, depending on frequency of your analysis. And as soon as you got this, you can combine your knowledge of value at risk estimations for model performance metrics, and the way we tried to translate statistical performance metrics of models into financial result. And here the kind of maybe some idea for future of model risk management is just to treat your models as an assets with random financial results, as it happens with financial instruments. They have random return, and these financial results happens or doesn't happen when we apply these models in business processes. And model performance are random time series in some extent, and we can model them. And of course, they correlate with some macro environment, because when macro situation changes, our estimations are not good enough. And also they depend on model on other models, because sometimes in big organizations, predictions of one model, for instance, probability of default, can be fitted into another model, which is risk-based limiting or risk-based pricing model. And if the first model performs poorly, it means that the latter one is going to be also not that accurate. And in this sense, a model portfolio, I think, can be treated as an asset portfolio. And this can give us a hint how to translate those, backward-looking estimates of model quality to predictive model performance, and to move more to value at risk like estimates of model risk within large financial institutions. So again, I think that the topic I discussed today was, I would say, closer to my background, to what I'm interested within financial industry and modeling within banking industry. And it's not that, I would say, standardized and well studied, and many things we discussed today is an open question. So therefore, I would like to answer your questions and probably to talk about the things you are interested in mostly. So at this time, I thank you for your attention, and let's discuss questions. Okay, now let's go through questions. Is there a model risk management framework for dynamically trained models with streaming data? Yeah, indeed there is. I think that the thing you're talking about is that there is some scheduled, there is schedule for model retraining when we have a new portion of data, and we feed this data to our model, and we kind of update its coefficients or update totally the whole model structure with features. It depends. The only way we have to be sure is that whether or not the model architecture is impacted dramatically. If this kind of retraining is not really deep, I would say, so we just update coefficients, the model architecture, the algorithm, the set of features is the same, then we just run a set of standard quantitative statistical tests for this model, and if they are okay, the model is deployed in its new version. If the model architecture was kind of redesigned and we see that with this new portion of data, the set of features was substantially reconsidered, and now model is looking at different features, then it's not that easy question, because we have to look at that with our eyes. So we involve a validator, because it may be a bad sign that something really changed maybe within our process, because for instance, 1 month has passed and we redesigned our model dramatically. So we have to check it. Follow up: is the model risk management framework implementable on cloud without changes? The open source framework referred to it on the previous slides. No, I think, unfortunately, maybe I put it wrong, but I believe there is not many open source solutions to that questions, because well, of course, you can find the libraries that allow you to build time series models, and you can apply them in order to solve your model performance prediction problem. But I wouldn't say that there are certain systems that allow you, as I said, like model library. That yes, SAS model risk management. This is the product which allows a bank or a company to track all model changes within business processes, to perform automatic validation, regular monitoring of the models, and to kind of share information between developers, implementators, and validators. So, but they're not open source; they're more like commercial. As far as cloud-based for banking, I'm not sure. I'm not sure, because every bank or financial institution, or even a technological company, they consider their models as know-how, and they're not very happy to share that in cloud. I think there's certain data that banks keep in clouds for sure, but they're not about those core business processes, I think. Say you're starting a lending company, you still don't have enough data to validate your credit risk model. What do? How do you begin with little to no data? Well, basically, there are several techniques to that point. The first one is to ask our credit bureau. Actually, in case of Sberbank, I think it's a very rare situation, because actually we have largest, almost, I think, in most client segments, we have largest market share, so there is no such problem for us. But if we take a small bank or a microfinance company, that they can ask credit bureau, and they can share some knowledge, some I would say aggregated information on whether or not this client segment is risky or not. Another point you can take from your client base, clients which are most similar to the ones you're going to provide loan with. You can do that by some propensity score matching, which came from medical industry, or you can run a pilot. You can just run a small. You can provide loan for a really small portion of clients, just to get some representative data. So this is different ways to solve it. Next question: data collection, understanding data is important in creating any model, and regarding validations, most important to get clear view whether it clearly objective the purpose of creating a model. Credit risk model might turn out to be direct and negative side, but the actual credit risk might be low with high credit score. What are the key values in the model that address these issues just in general? Basically, the thing we're looking at are, I think you're talking about false positive and false negative errors. So, and also we'll look at acceptance rates. So, suppose you have rebuilt your model, and then it goes through validation, and the business owner says, so if we keep this threshold rule, that then the percentage of clients that are accepted increases. So he's happy about that. And suppose that the new model is better than the previous one in terms of risk assessment, and kind of with the same default rate, it can allow to provide more loans. It means that with the same or lower default rate, you can increase your accept rate, and you can try to calculate it on historical data too, in case if they're representative. Well, next one: do you optimize overall junior separation around probable cutoff? A very great question. I think I'm really sorry if I pronounce it wrong, Gianluca Cataldi. It's a very good question because, of course, Gini itself is an aggregative matrix, and of course, we look at increase around our cutoff probability because so basically there are two things. The guy he's talking about. Um, well, let's take an example of call center, and imagine we want to communicate to our clients and offer some products to them, but the fact is that in our call center we can make only 100 calls per day, but in our client base there are kind of like a million clients. Okay, it means that we can build very good model on our 1 million client, but our capacity is limited with 100 clients per day. It means that we have to maximize not overall Gini for 1 million client, but we need to, so to say, maximize uplift of our model based on those 100 top clients. So we pick 100 top clients in terms of probability of response, or better say incremental in probability of response, and we communicate with them. And if basically it's a very good question. So of course you have to look at the area of your cutoff. Do you have any portfolio, website, or GitHub repo where you can see list of your projects? Well, I have some page in LinkedIn, but when it was blocked in Russia, I stopped updating it, so it's a really old one. I have my page on Higher School of Economics. You can visit that page. Personally, me, concerning repos, I'm not, I would say I not code myself. I'm more like team lead. So I used to do that. I have some personal repos at Bitbucket. If you're interested in them, I can provide them. What are the best resources to learn more about metalearning for model management? Thanks. Well, I would start generally from metalearning. There is a number of really good articles. You can visit archive.org. So archive, it's a great collection of different papers concerning machine learning stuff. Well, there's a certain number of works concerning metalearning. So feel free to Google it or to look at archive.org. Which skills and knowledge are essential for building efficient models? So obviously all of them above. I would say must-haves, because nowadays the most valuable people are the ones who kind of have 2 or even 3 backgrounds together, because it's not enough to get only one area in order to success within your job market. It's better to have intersection. Interesting webinar, thank you. Can you share more examples for the implementation use black models? Maybe share a link about it. Oh, of course, I think I can. I think we will provide it after webinar. But actually, black box models, you can take some Deloitte reports, or the ones I'm gonna show you on this first slide with McKinsey report. I used a footnote. You can see it in below. McKinsey Global Institute Evolution of Model Risk Management. It's a big survey that they conducted in 2017. It's devoted to model risk management, and also they cover some machine learning things within financial industry. And they have a separate survey about using AI in banking. It's also very interesting. So Google McKinsey surveys on those topics. I think it's a good thing to start with. An out of syllabus question, sorry, no problem. Is it advisable to use custom versions of binary multi-class cross-interpolation and deep learning models to higher weights to 1 or more classes and optimize over net cost scores probability values will be skewed? Oh man, sorry, it's It's late hour in Moscow, and I'm way after my working hours to answer that. I can send this question to a colleague of mine. He's very nice guy, Alexey Azurin. He runs a deep learning course within another master program. He's really great with that. So okay, so which skills and knowledge are essential for building efficient us? So yeah, all of them. Yeah, all of them. All of them. You know, like when they asked Chuck Norris how many push-ups he can do, he said all of them. Can you suggest a course for a good job? I advise you strongly to enter our online master program for data science. Again, for if you want fundamental, if you want fundamental education, you better run for our online master program in data science, because you can take this or that course, but they are not going to be well connected with each other, I think, or you will spend a lot of time just to kind of to choose and pick the ones that are really suitable for this number of for this area, because there are too many courses in the internet, so it's a really very I would say hype area. So that's why it's a good thing that within online master program all courses are well connected with each other, and they are really of high quality, and will provide you everything you need to build models and to apply them in business processes. Because the auto check is able to identify future decay while the model is not able to improve by time with new data. A very good question. The answer here is the following. For instance, you have data for the last, I would say, 12 months. And on those 12 months, you can observe volatility of your model performance metrics. It means that you can at least build some distribution of this. You can simulate, which is called historical Monte Carlo simulation, when you just pick up those increments within your history. You do it many times, and you plot a distribution that shows you possible monthly increments or decrements of model performance metrics. And as soon as you possess this distribution, you can take its average, for instance, to understand is there average trend for decrease, or you can even take some quantiles and use them as those kind of model risk limits. Another way is to find that some model features that were used or within the model development or significant to model are going to be, dramatically influenced by some process amendments in future. For instance, transactional activities. Suppose that we built our model on the data with rather high transactional activity, and we would like to offer some loans or products to our clients who are not that active up till this moment. And it means that to some extent our prediction was biased, and we can kind of control for that by subsetting our initial historical data set to that clients who are more similar to those we're going to apply model to. And we can kind of recalculate our model performance on this subset of clients and kind of extrapolate this and say that this is how we expect our model to decay. So there is number of variations. Does Sberbank have any vacancies related to this in Moscow? Sure it has. It has lots of them. I would say that usually the top time for hiring is start of a new year. So I mean, like in February, because in the end of the year, usually people are closing the year and there are lots of reporting activities and actually interviews and stuff may have take some time, and it's better to apply, I think, somewhere in the beginning of the new year. We have many job opportunities for data scientists. Well, I think that's it for the questions now, and I would like to give my word to my colleague, Khatuna.
Yeah, Alexey, thank you so much for your presentation. And I would like to say that the recorded version of that webinar will be available in a few days, so you'll receive the information via email. And thank you for joining us this evening. Have a good day. Have a good week. Wish you good luck. Stay safe. Bye.
Bye-bye.